Okay, in this video I'm going to be looking at how to find the gradient or the tangent line between 2 points and how that is like stepping into our using our derivatives, and also a little bit on limits. So we've got our case here where we've got P and Q. We know that they are h apart, like so that Q is 3 plus h. So if we had our coordinates down there, we'd have 3 plus h. We don't know what h is. And so then we've got the y coordinates given to us of a 3 here, and the other part is just where that has been subbed in to our rule. So we've got negative x squared plus 4x. So where we're seeing an x, we're writing 3 plus h. So we've got negative of 3 plus h squared plus 4 outside of 3 plus h. So what we're going to do is our usual process of finding that rate of change between those 2 points, where we would have the two y coordinates on the top subtracted. So we would have our negative outside of 3 plus h squared plus 4 outside of 3 plus h, and we would be taking away from that the 3, which is our second y coordinate, our first y coordinate, sorry. Then on the bottom, we would have 3 plus h, and we would be taking away 3. Now, straight away, you'll notice on the bottom, you get a h. You're going to see this whenever you're doing derivatives from first principles. You'll always end up with that h on the bottom. Now, on the top here, we're probably going to want to expand this out to try and simplify it. So to expand that out, I've got my 3 plus h squared. I'll do that first and then put the negative onto each of them. So that would give me 3 squared plus 6h plus h squared. And then I would, expanding that out, I get plus 12 plus 4h, take 3. Then I'm going to apply that negative to each. I know 3 squared is 9, so I've got negative 9. I've got take 6h, take h squared, plus 12 plus 4h, take 3, still over h. And then I've got, looking at what I can simplify, so I've got negative 9. I'm adding 12 to that, so that would give me positive 3, and then I'm taking 3 away, so that gets rid of my constants. Then I've got minus 6h plus 4h, that would be minus 2h on the top there, and I've got minus h squared over h. Then I'm going to factorize that, so I'm going to take out a h out the front, and I get minus 2, and that would be take h over h. I can then cancel my h's out, and I'm left with negative 2 take h. Now, as h approaches 0, and this is the big factor in these that we consider, so as h approaches 0, what is negative 2 minus h going to approach? It's going to approach negative 2. So that gives us our answer there. And looking at our picture, does it look like it has a negative gradient? Yes, it does. So that makes sense. We can also see this in the form of where in this same exercise that this topic comes from, we have our limits. So we also see it in this format, which is how you're going to see your derivatives from first principles in this format as well. So the limit as h approaches 0 of this. Now this looks just like what we had in that previous question where we had the h on the bottom and we had some things on the top. So we're going to do the same thing again, and we're going to look along that line. They all have a factor of h. So we get 2x squared plus h squared plus, plus h squared times h squared plus xh plus 1 over h. We can cancel that out, and we get 2x squared h squared plus xh plus 1. And we're going to want to factorize that because it's in the form of a quadratic. So we need to try and factorize that to then be able to hopefully solve it. Or we can use the process of going, okay, as h approaches 0, what's going to happen to this function? So as h approaches 0, then that would become 0 because you've got 0 times that. As h approaches 0 here, 0 times x, that's going to be 0 as well. So we're left with 1. So as h approaches 0, that function is going to approach 1. So the limit as h approaches 0 will be 1.